Again, let us know if you have any question or you need help on anything. You can just unmute yourself and talk or type in a chat if you want to. Right, it's been 10 minutes. Any one of you need more time? Are you guys done with the question? Okay, almost done? Okay, I'll give you 2 more minutes. Alright, let's take it up. So for question 1, what kind of problem is it? Anyone know? If you need to
An
classify the problem.
optimization problem?
Exactly, optimization problem. Okay, so for optimization problem, your first step, you need to read and you need to understand the problem. You need to find your variables, find what are you trying to optimize. So let's try that. You have a 3 feet by 8 feet piece of cardboard. So let's draw the cardboard out. And here is 3, here is 8. Now you're cutting some congruent squares from corners and fold up the sides. So let's cut some squares at the corner. Notice that each of the square, they have the same length and width. So let's call this X. This will be X as well. Okay, and then you are folding this to a rectangle box like this. Okay, like this open rectangle box. So if you fold it up, it's gonna look something like this. Uh, this might not be perfect, but I think you understand what that meant. Now my question is, what is the length of this part? Anyone know? So I'm folding this to this. What is the length of this part?
Would it be 8 minus 2x?
Exactly, 8 minus 2x. What about this part?
3 minus 2x.
3 minus 2x. What about the height of the box?
That would just be x.
That will be just x, yes. Alright, so we have all the informations. Now they ask you what are the dimensions of the squares that optimize the volume of the box. So, volume of the box. What is the volume of the box? Anyone know what's the volume now?
8 minus 2x times 3 minus 2x times x.
Exactly. Times x, okay? So we need to find the maximum value of this expression. What's our next step now?
We expand it and then find the derivative.
Well, yes, but before we do that, there is something you need to be careful with. Okay, you need to find the domain first, right? So what is the domain of this question, of this function? Well, we know x has to be greater than x, or greater than 0. We know 3 minus 2x has to be greater than 0. And we know 8 minus 2x has to be greater than 0. Because all those lengths, they cannot be negative. Okay? So if you solve this, this will give you x is less than 3 over 2. And this will give you x is less than 4. So the domain of this function will be x is in between 0 and 3 over 2. Now we can do what one of you said. We expand this and take the derivative. So what do we get after we expand this? So v of x equals to, what do we get after we expand this?
You get 4x cubed minus 22x squared plus 24x.
Minus 22x squared plus 4x. 24x. Okay, So this is your volume, and one of you said let's take the derivative. So what's v prime of x?
12x squared minus 44x plus 24.
Exactly. All right. Then what do we need to do? How do we find the maximum or extremal value of this, of the volume? Anyone know? Well, you need to find the critical point of V. And how do we find the critical point of V?
You solve it, make it equal to 0 and then solve it.
Okay, make it equal to 0 and solve it. Exactly. Okay, so let's make it equal to 0 and let's solve this. So this will be, let's divide by 12. That's gonna give us x squared minus 44 over 12x plus 2 equals to 0. And then you can simplify this, divide by 4, that's 11, that's 3. And then you can do factorization. This will give you x, oops, wrong color. This will give you x minus 3 times x minus 2 over 3 equals to 0. Now, can someone tell me what's my critical point in this case?
2 over 3.
Critical point is 2 over 3. Why do we discard 3?
Because it's outside the domain.
Exactly. We discard x equals to 3 since it's outside of the domain. So it's not in our domain. Okay, so we found our critical point. How do we know if it's maximum or minimum? What do we need to do? Well, we know we need to maximize it, but what if it's a minimum value? How do we check if it's max or min? So now let's check. If it's maximum, what we can do is we can take the second derivative and see if the function is concave up or concave down. So what's v prime prime of x? Anyone? What's v prime prime of x?
24x minus 44.
Exactly. Okay, so the second derivative at this critical point, we can put it in. So v prime prime of 2 over 3 equals to 24 times 2 over 3 minus 44. And this will give you 16 minus 44, which is negative 28. This is less than 0. So since this is less than 0, what does this tell us about the function? Is it concave up or down?
Concave down.
Okay, so the function is concave down. Since it's concave down, do we know if our critical point is max or min?
Max.
Max, okay? So therefore, x equals to 2 over 3 is the max point. And we know it's the absolute max point because we only have one critical point. Oops. we have unique critical point. Okay, so we found our x. Now the question asks you the dimensions of the square. Now you just need to plug in 8 minus 2x and 3 minus 2x. Okay, so the dimension of the square is, so 8 minus 2x equals to, what's 8 minus 2x? (20/3), and then 3 minus 2x equals to 5/3. Okay, so the dimensions are dimension of the box is 3 by 5/3 by 20/3. Alright, that's it. Any question? Question? Anyone has any question? No questions? Clear? All clear? Okay, no question, then let's have a look at question 2. Again, we'll give you, I don't know, how much time is good, Peyton? 10 minutes?
Yeah, I think 10's good. That's good.
Yeah, okay. We'll give you another 10 minutes to work on this, and then we'll take it up.
Sorry, do you mind going back to the previous question for just 1 second? Just the ending. That's perfect. Thank you so much. I'm good.
Hi guys, so it's about 10 minutes. I know some of you guys are a bit confused about question 2A and 2B, so why don't we do question 2A and then I'll guide you step by step for 2A. So the steps for 2A are going to be pretty similar for 2B. So if you understand 2A, then it will be easier for you to do 2B as well. Okay, so while I'm talking about the answers, just let me know which part are you stuck on it. So some of you guys are telling me that you don't really know where to start. So first of all, for this question, so they're asking you to find the antiderivative here, right? And they also gave you the initial value. So whenever you're finding the antiderivative, how do you find it? Anyone? So if I give you f prime x, okay? And then if I want to find back f of x, how do I do that? So in order to find back the antiderivative, right? So this is actually, we'll have to use integration, right? So that's how we find back the entire thing for f of x. And that's what the question is actually asking here, find back f of x, right? So your first step for part A here, what you want to do is to take the integral because they're asking for f of x, okay? So notice that when you have this expression here, whenever you have this entire expression here, you get back f of x. So right away, if I have the integral of f prime x dx, what does this get me? Does anyone know? You get back your f of x, okay? So this is integrating just the left-hand side, okay? So you're expecting to have something like this on the left-hand side. What about the right-hand side? Right-hand side, you have the function of this, minus 3 cosine 2x plus x to the power 3 over 2. Now we have to do the integration as well because when you're integrating the left-hand side, you have to do it for the right-hand side as well. So this notation basically means that you're integrating with respect to dx. Okay, so don't put anything here except for x or else the entire thing will not be valid. So how many of you guys have solved for the integral here? Can you let me know in the chat if you've solved for it? Okay, no worries, then we can do it together. So if you haven't had the chance to solve for it, let's do it together, okay? So, well, integrating for this, we can actually do it term by term, right? So what's the outcome after you integrate minus 3 cosine 2x? So we can simplify that for a little bit first, okay? We can take the constant out. So we have a constant here as minus 3. This will be just integrating cosine 2x, right? And then dx. I'll split that into 2 terms so it's a bit more clear for you guys. Then after that, we take the integral. We integrate it. So after you integrate for cosine 2x, this will change to minus 3 times sine 2x over 2. And then for the next term, this will change to 2 over 5 x to the power 5 over 2. Am I missing something? Or is that it for the right-hand side?
You have to add c.
Exactly. Thank you. Because this is not definite integral. This is indefinite integral. So you have to add c here. Again, if you're not familiarized with the steps here for integrating, or if you're not sure about your answers, you can always differentiate it back to see if you get this answer. Okay? All right, give me 1 second here.
Sorry, I was gonna move your work app, but
No.
somehow
Sorry,
it didn't work. Let me try again. There we go. Okay, now you have more space to write.
Okay, thanks. So, wait, I need the question though. Because I need the values. Okay, that's it. Okay, that's good. You can just scroll down. So they gave us f prime equals to 0 as well. So this is another information that the question gave you. So does anyone know what this information, like how does it help us to find f of x? So I'll give you guys a hint here. It relates to your constant term. So just now, a student say that you have to add the constant term, right? Giving this f prime 0, this is the original function, right? This is not, sorry, this is f pi 0. This is not f prime x anymore. So this is just the original function, right? So as I mentioned here, now your f of x can be rewritten as this, -3 times this, plus this, plus c, right? So if I plug in pi here and it gives me 0, that means I can actually solve for the constant. Does that make sense? So if I plug in pi here, because these two functions are equivalent, right? So if I plug in pi as the x value here, I only have to sub in the x value as pi here. So we're having sine 2 pi divided by 2 plus this times pi to the power this plus c. And the last thing is, what does this tell us? This equals to 0, right? So setting this equal to 0 means that we can actually solve for c. So does anyone know what this will give us? Just the first term.
Zero.
Yep, exactly. So you can actually visualize it by using the graph, the sine graph, right? If you have 2 pi here, this will just give you back 0. Okay, so the first term here is just -3 times 0 over 2 plus this plus c equals to 0. Okay, so this term is completely canceled out because this will just change to 0. So now we have c equals to -2 over 5, pi to the power 5 over 2. So plugging it back into the f of x equation, we'll have our final answer here. So I'll just write it on top. Don't worry, I'll just write it on top here. So final answer here, we'll be having f of x equals to -3 sine of 2x divided by 2 plus this, and then minus 2 over 5 pi to the power 5 over 2. Any questions so far? Okay, where's the 5/2 from? Give me 1 second. 5/2, are you saying about the last step? Like the blue line, the last line? You're talking about this one, right? 1 second. This one? This one, if you're talking about this 5/2 here, this is taking the integral of x to the power 3/2. So I'm basically using the rule if I'm taking the integral here. If I'm integrating x to the power, say for example, x to the power 3, right? Dx, how do you integrate it? You use 1 divided by 3, which is the power, plus 1, and then x to the power 3 plus 1, right? So same thing here. What I'm doing here is that I have 1 divided by 3/2 plus 1, and then x to the power 3/2 plus 1. I just simplify the entire fraction here. Does that make sense? Okay, so we're a bit tight on time, so let's talk about the next question as well. The next question will be having the same method in terms of solving. So
I took a screenshot and sent it to the chat about this question solution. So I'm gonna erase everything here, and then we'll move back to the question.
okay, sure. We still have one question, right? Yeah. Okay. Okay, so for this question, it's gonna be the same method in terms of solving. So just now, let's have a recap, just in case if you don't remember. The first thing is always to integrate it, because now they're giving us what? They're giving us dv dt, which means this is basically v prime t. Does that make sense? So just now the question gave you f prime x, so you want to integrate it to get back f of x. Now you want to integrate this to get back v of t. Okay, so whenever they're saying find v is to find a function v, this is equivalent to v of t as well. Okay, so first step is always to integrate. Second step is to find out your constant value by using whatever they gave you here, right? V of 0 equals to 1. Okay, and then last step is going to be expressing v in terms of something else. All right, so now we have v prime t here equals to this function right here. So integrating both sides, the left-hand side will give us v of t, right? Right-hand side, if we integrate it, let's just have the symbols here before taking any steps further. So when we integrate this, we'll be having this expression. Again, now we can actually split it out to 2 different integrals. So the first integral that we have here will be having 1 divided by 1 plus t squared dt plus this. Now, does anyone know what will the first term give us after integrating it? Does this look familiar to you? Have you guys learned it during the lecture? So if you don't remember it, it's okay. You should have seen it somewhere. It should be in the textbook somewhere. I'm not sure. But if you don't remember it, now you should remember that this is going to be equal to arctangent t. You can try that out again on your own. If you differentiate arctangent, you'll get back this. So if you integrate, you'll get back arctangent. What about the second term here? What does this give us?
Tan T.
Tangent t. Okay, thank you. Again, this will be having the plus c here, right? So now we completed finding just the v of t term, and the next step will be finding the constant c. So using the formula that they gave us v of 0 equals to 1. So we can say v of 0 here equals to 7 arctangent 0 plus tangent 0 plus c equals to 1. Now, what's the value of arctangent 0? Does anyone know? Not pi over 4. When I'm doing these kind of questions, it's always good to refer back to the graph. At least that's one of the methods that I always like to use. So if you remember the graph of arctangent, how does arctangent look like? Arctangent looks like this for the graph here. So this is the graph of arctangent, right? So when it hits 0, it gives you back 0 as well. So this part is just 0. What about tangent 0? Tangent 0 will still give you back 0. If you take a look at the graph, 0 again, it gives you back 0. So this will still be 0 here, plus c equals to 1. So which means 0, 0, and then c will just be 1. Right, so at last, the function here, vt, this will just be 7 arctangent. So you can actually write arctangent or the inverse tangent like that, plus tangent t plus 1. Any questions so far? Okay, so try to practice these examples again at home because I know you guys, maybe you're a bit stuck on it, and make sure you follow these 3 steps. First is always to integrate, and then you find out the corresponding constant, and then sub the constant back to find the function itself. Okay, any questions so far? And I guess that's it for this tutorial. And thanks for coming.
Yeah, thank you for coming. Copy, there's no copy. I'll take a screenshot and I'll send it to you guys. Hopefully that's good. Also, I drew the graph of tangent and arctangent on the side. Okay, there we go. So there is a screenshot that shows the solution of this question, and that is the end of this tutorial. I think this is the last tutorial of 132. Good luck on your exam. You have an exam, right? Yeah. Nice seeing all of you, and good luck on your exam. That's the end of the tutorial. Bye, guys.
Thank you.
The screenshot of question 1 is in the chat too. This is a screenshot of question 1. Okay, bye, guys.
Thank you.
No worries. Bye.
Bye. Okay, I'm gonna go too. I actually have work now. Bye, Peyton. Bye, Dart.